The following is a conversation with Sammy Madhi, the Senior Project Engineer at WaterScope. WaterScope is an organization with a goal to provide safe drinking water to everyone, and they're using machine learning to do it. They also recently won the Cisco Global Problem Solver Challenge of 2021, which is an annual competition that awards cash prizes to early stage tech entrepreneurs solving the world's toughest problems. I hope you enjoy the interview. Okay, hello. Thank you so much for joining me today.
Thank you for the invitation.
Yeah, of course. So I'd love to start things off with, if you could just tell me a little bit about WaterScope.
Sure, yeah. So WaterScope is a spin-out from the University of Cambridge. We were founded 5 or 6 years ago now. And what we're trying to solve is the problem of water inequality around the world. And we're trying to achieve that by developing a system that is easy to use, digital, and affordable.
Got it. And so can you tell me a little bit more about like the problem that you all are solving?
Yeah, so globally, around 2 billion people drink contaminated water every day, which leads to significant health consequences. And I think 500,000 people a year would die from waterborne diseases. And we think one of the reasons why this problem is so widespread is because people don't actually know what's the quality of their water. And yeah, we're trying to solve that problem by providing a system that anyone can use at any place.
Got it. Great. And can you tell me a little bit about yourself and maybe your background and your role at WaterScope?
Yeah, so I'm Sammy, so my background is in electronic engineering. And I also almost have a PhD in nanotechnology, but I've joined WaterScope on the side during my PhD. And basically my role at the moment is basically lead engineer. So I'm responsible for the prototype development, overseeing the software development, establishing a supply chain, and just in general, whatever company business there is.
Got it. And you're a small team right now, or how many people do you have on board?
Yeah, so we have 3 full-time people, me, Alex, and Alicia. And we also have part-time helpers that, would commit, 10, 20 hours a week. So we have maybe 4 or 5 of these. And yeah.
Cool. That's great. And so, I kind of discovered you guys because you were winners of the Cisco Global Problem Solver Challenge, which is amazing. Congratulations.
Thank you.
And in this great article that they did of you guys and an interview with your CEO, they talked about how you all are using machine learning in your product. So I was wondering if you could tell us a little bit about that.
Yeah, I mean, first, as a sort of background, the way that the WaterScope system works in 2 sentences is we have a water sample that we want to test. So what we would do is we would filter all of this water through like a tiny filter paper. Then we would add some nutrient media to that filter paper, and then the bacteria on that filter paper that we've captured would grow over time and change color. And then once we have these colored bacteria, we will take an image of them with a microscope. And then this is where the machine learning comes in. We need to quantify how many bacteria we have and also identify the type of bacteria. So the type, we just look at the colors. We have blue colonies, which are E. coli, and we have purple colonies, which are purple pink, which are other coliforms. So just based on the color, we can tell what the strain is. And then with the machine learning algorithm, we also count how many colony forming units we have, which is essentially what we're looking for is 1 bacteria in 100 milliliters of water, which is quite small. And yeah, the machine learning part helps us identify these colonies because sometimes they're quite faint, so you can't exactly see them by eye. And the other problem is, so if you have 150 of those tiny colonies on your filter paper, counting them by hand, like manually, it's quite a tedious task. And you also need to be quite an expert in the field to actually be able to tell apart whether the region that you're looking at is, if it's a bacteria or like some sort of debris from your sample.
Got it. So can you tell me a little bit about the data that you work with? Is it mainly images?
Yeah, so we work entirely with image data. So we would capture a very high resolution image, which is magnified through a lens. And then we have a 12 megapixel camera. And then we would do some very basic image processing. And then we would sort of scale down everything so that it can then be fed into the machine learning model.
It's very cool. And so was that the original plan for the product, to use machine learning, or did it kind of evolve?
So we weren't sure initially whether we would need a machine learning solution, because you can, like these type of problems, sometimes you can approach them with a traditional image processing. And basically over one summer, we had 2 projects running in parallel. We had a more traditional approach with these image processing techniques, like using ImageJ and OpenSeal and so on. And then we also had a more wild machine learning project that would basically look at how we can use that. And after 3 months, initially the image processing approach was giving better results, but then over time the machine learning sort of kept getting better and better and better, and then until the end it was very clear that the machine learning approach would give better results given the amount of data that we had and also the internal expertise of the team. So that's sort of how we decided to stick with machine learning.
Wow. And has it been easy? What kind of challenges have you all been tackling as you use machine learning?
So, I mean, there were obviously the technical challenges of, getting the right amount of data, labeling the data, training the algorithms. And yeah, that was, there we sort of managed, but a bigger problem that we had is finding the right people to do this work for us. So at the moment, the sort of high-end machine learning engineers, they're being scoped up by, Google and Microsoft and so on. So, it's not exactly appealing to tell someone, oh, well, can you do like a little project for us? And like, we'll pay you maybe something, maybe not. Yeah. So in that regard, we were quite lucky because we were working with a student in Cambridge who had, quite a bit of interest in machine learning. So he was still early on in his career. So he was, willing to work with us. But for example, at the moment, one of the challenges that we have is like, how do we get someone on board that has that expertise and doesn't want to, charge us a lot of money? So. Yeah.
And it's definitely a big challenge, but hopefully, with this kind of a problem, it's so inspiring that, I would imagine that people who get in this business to solve big problems are the kind of people that would be coming to you guys, hopefully.
Yeah, hopefully.
Yeah. So do you see opportunities for growth with machine learning? Do you see kind of using it more in the future or differently in the future?
I think so, yeah. So one of the advantages of our system that we have is basically we can, so at the moment we look at E. coli bacteria in water, but there are like other types of bacteria that we can look at. So like cholera or I'm not the biologist, so but basically by changing one ingredient in our sort of nutrient media, we can look at different bacteria. Now, if you have to like do a new algorithm every time with like traditional image processing, that's quite a tedious task. Whereas with machine learning, the way that we envision it is we just, collect the data, label it, and then we pass it to the same algorithm that we've developed before. And this would allow us to really expand our portfolio in terms of what type of water tests we offer. The other growth opportunity for us with machine learning is bringing the time to detection earlier. So at the moment we look at 18 hours, but we for a fact know that at 9 hours, the bacteria, they're visible already. So the question is, can we now train an algorithm that can identify these bacteria even earlier, so say at 6 hours? Because there are some faint changes to the way that our image looks at 6 hours. And we think that for a machine learning algorithm, this would be easier to distinguish than for a human eye. And this would, again, make our product much better.
Yeah, I mean, that's a big difference, 9 hours versus 18 hours.
Yeah.
And so what do you see for the future of machine learning? I mean, I think you talked about it a little bit, but for the future of machine learning in your product potentially, but do you see kind of like outside of your product in this field that you are working in?
So we've,
future?
what we would like to see in the future, and what I think might happen is, there will be more and more sort of no hands machine learning services. So you would have, you wouldn't need a machine learning specialist to be able to leverage some of the, the novel stuff that's happening out there. And I think, there are quite a few promising platforms at the moment that, would at some point allow us to not have a machine learning specialist on our team, but just feed the data, and then the tool will sort of take care of that. So this is what we definitely see in the future, because I think training enough machine learning specialists is a challenging task.
Yeah, absolutely. And, especially for a small team, introducing machine learning, as you talked about before, bringing on a specialist can be very daunting and, takes a lot of time away from the team. Yeah. Well, cool. And then I also wanted to ask you, are there ways that people can support WaterScope?
So you can sign for our newsletter on waterscope.org, where we send updates. You can follow us on Twitter, and we're always looking for people to help. So even if you're not able to commit, 20 hours a week, even, a couple of hours a week, we would be more than happy to welcome you to our team. So just, get in touch through our website, and we can find something.
Awesome. Yeah, I love what you guys are doing. I think that, I hope in the future we see machine learning and AI more in international development and supporting, people in other countries. So thank you so much.
I mean, there are big opportunities at the moment. So
yeah, definitely. Okay. Well, have a wonderful day.
You too.
Thank you.
Bye.
All right. Bye.